Okay, geometry, section 10.4. It's kind of a tricky section. We start talking about regular polygons, which are going to be like these pentagonal shaped things inside of a circle here, or it might be a hexagon or an octagon shape, and we're trying to find the area of those, which is kind of tricky. But once you kind of have it figured out and think about it, it's pretty easy. And then composite figures is on the back side. We talk about like figures that are all shoved together and finding the areas of different pieces and adding them all together. So kind of a tricky section, but bear with me. They break this apart, this figure here, and they start talking about the pieces of it. So the center of a regular polygon, the center is at P. Okay, so even though these are labeled on here, I'm going to label them off to the side over here so we can kind of go through this as we label. So center is at P. They want a radius of a polygon. Okay, so on here I have the circle on the outside, and then the this pentagon is inscribed inside of that. Okay, so this is inscribed. I actually have two radius lengths listed here. One of them is BF, okay, because it's going from the center all the way to the outside of the circle, and the other one is PA, going from the center all the way to the outside. So these are both radii, okay, radii of the circle. And then they have something called an apothem, okay, which is kind of a fun word. An apothem, this guy right here, is going from P to the outside of this polygon. So it doesn't go all the way out to the edge of the circle like a radius does. It goes from the center just out to one of the edges here. Okay, so this would be another apothem from here to here. It makes a 90-degree angle with the outside edge. Okay, so here's an apothem, here's an apothem, here's an apothem. Okay, those guys there, those are all apothems. Okay, and then we have a central angle. So looking back at this triangle right here that they first had labeled, okay, the central angle is going to be this angle inside of here. Okay, and they want to know how large that is. Okay, so what I know is that this triangle right here is 1/5 of the circle. Okay, and I know that that's 1/5 because this is a 5-sided figure, right? If I make him into, 4 more, or I make 4 more of these, there'd be one here, one here, one here, and one here. There's 5 total of those things in there. So this little piece right here, that central angle, is 1/5 of the entire circle, or the entire pentagon. Okay. Now, if I want to figure out how many degrees this is, 360 would be all the way around. I just divide by the number of sides that I have, which in this case is 5. So 360 divided by 5 is like 72, I think. 360 divided by 5, 72, yes. So each one of those central angles is going to be 72 degrees, okay? And that's because I took 360 divided by the number of sides, basically, there are in this figure, okay? So lots of vocabulary and stuff going on here. Let's see if we can answer some of these questions. Example 1. In the figure, this square is inscribed inside of the circle. Okay, so I have a 4-sided figure. Identify the center. Center is K. Done. A radius. Okay, so there are actually 2 radii labeled here. One of them is KG. KG. The other one is KH, because they're going from the center to the outside of the circle. They're touching the edge of the circle, okay? They want to know what an apothem is, so label an apothem. There is only one apothem labeled, and that's going from the center to the edge of the square, so that is KL. And then they want a central angle, okay? There's only really one central angle. There's only one angle that's at the center, which is this guy going all the way across here. So labeling that central angle, I'm gonna go over here, central angle. Labeling that central angle would be, if we start at G, we go to K, and we go to H. So it would be angle GKH. Or you could say angle HKG would be another central angle. So we're looking at that central angle. Technically, GKL, this little half of that, would be a central angle as well. But usually when we're looking at composite figure, or at regular polygons like this, we're going to do the whole piece as a central angle. So GKH or HKG, that whole thing. Then they want to know what the measure of that is. Okay, so how many of these angles will be all the way around? Well, how many sides are there? 1, 2, 3, 4. If I take 360 and divide by 4, that's 90 degrees. So this guy right here is a 90-degree angle. Okay, and that's what my central angle is. Okay, we'll go through this one just a little bit faster. It's the same type of thing. Center of the circle is R. Radius is RK or RL. And apothem is RS. RS is one of the apothems. A central angle, I'll do that over here. Central angle, this guy right here is angle KRL or angle LRK. We always want to put the R in the middle. And then 360, how many degrees is this guy right here? 360, I would divide by 1, 2, 3, 4, 5, 6 sides. So each one of those is going to be, I can't divide. 360 divided by 6 is 60 degrees. So each one of these angles right here going all the way around. So if I would make all of my triangles go all the way around, each one of these would be 60 degrees. 60, 60, 60, 60, because there's 6 of them, okay? All right, now they're gonna ask us some area questions. So how do I find the area of that thing? This is a, let's see, how many sides does this have? 1, 2, 3, 4, 5, 6, 7, 8. An octagon. So 8 sides. Okay, so keep that in mind, 8 sides. All right, if we're trying to find the area of this thing, they kind of have this labeled out here where I have this bottom section, okay, and kind of like a piece of a pie almost. This guy is going to be like a triangular shape that if we're trying to find the area of the whole thing, if we just find the area of this triangle and multiply that by 8, that will give us what we want, okay? So they're telling us that the side length is 15 inches, okay? Side length here, this bottom side here is 15. I'm gonna label this a little bit better. I'm gonna take that triangle and I'm gonna section him out over here. So 15 inches is that bottom side, and it says the apothem, which is this guy right here, is 18, okay? Well, since this is a triangle, and we know how to find the area of a triangle is 1/2 the base times the height. I would have 1/2, base is 15, the height is 18, okay? And what I'm gonna do, I'm gonna take half of 18 first, because I can do half of 18 really nicely. Half of 18 is 9, so I take 9 times 15. 9 times 15 is, I don't know, something. 135. 135 inches, okay? So I'm just finding the area of that triangle. 1/2 base times height, 135 inches squared is what he is, okay? That is just one of these pieces, but there are 8 of them going all the way around. So that 135, I would just take that times 8, and that would give me my area of the entire thing. So 135 times 8 is 1080 square inches. That's what the entire area of that figure is, okay? So a little bit confusing there, but just like think of these in terms of a bunch of triangles going all the way around. That's exactly what they all are. And depending on how many sides your regular figure has, depends on what you're going to take that triangle area times at the end. This one was times 8. This would have been times 6 if we were finding the area of that guy, okay? All right, they give you the equation of an area, and I don't like that area equation because that doesn't make very much sense to me. So I'm going to put this, I'm going to do this area of triangle times number of sides. Okay, this is the easiest way to find it. The area of the triangle times the number of sides. Okay, so let's go to the back side and let's answer some of these questions. Oh, my paper is like bleeding through because I'm marking too hard. Okay, so let's do like part B. We'll skip part A because part A is kind of the same thing as what this one is. Okay, so we'll do part B. A regular pentagon. Pentagon means 5 sides. So I'm going to write that down, 5 sides. So as soon as we find the area of this triangle in here, we're going to multiply that by 5. Okay, so I'm going to get him ready to go. We need to find the area of this triangle right here, and I've sectioned him off over here. The radius or that slanted height is going to be 10. Yucky, yucky, yucky. I don't like this. Yucky. Okay, so that slanted height is 10. We need to know the base, which is this bottom side here. Ugh. And I need to know the height, which is that guy there. And I know neither of those things. Crap. So what I need to do is, I know that the fact that this is a 36-degree angle. Okay, so let's do some work here. Okay, this guy's 10, this guy's 36. Okay, we'll call this base, and we'll call this guy height. Okay, so this base right here, if I'm trying to find him, I can use SOHCAHTOA. SOHCAHTOA. Okay, SOHCAHTOA. All right, and this is 36 degrees. So let's say we're trying to find B first. Okay, B is going to be the opposite, and 10 is going to be the hypotenuse. Okay, so which trig function are you going to use when you're doing opposite hypotenuse? We're going to use sine. So I have sine of 36 equals base over 10. All right, and then to find that base, that bottom side, I'm going to multiply by 10. So I have 10 times sine of 36. Let's do that. 10 sine 36. And we get 5.88. The base is 5.88. Now, we have to be careful. 5.88 is only going to give me this side of the bottom. So if I want to find the entire length of the base, which is what I need to double that. Okay, so I'm going to take that times 2 now. So technically it wasn't the entire base. Let's go 11.76 is the bottom, 11.76, okay? That's going to be what the base of this triangle is, 11.76, okay? Now I'm going to do the same thing again. I'll use a different color to find the height here, okay? So I'm going to use some trig function to find height. So if I'm using 36 here, height is going to be the adjacent side, and I still want to use 10, which is the hypotenuse side. So adjacent and hypotenuse, that's going to involve cosine, okay? So I have cosine of 36 degrees equals, the adjacent side is h, the hypotenuse side is 10. So same thing there, I'm going to multiply the 10 over to find out what my height is. Okay, so 10 cosine 36. 10 cosine 36. Okay, if I'm going too fast, pause the video so you can kind of catch up a little bit. This one is 8.09 is the height. 8.09. Okay, now we don't have to double that because we were finding the exact height there. 8.09. Okay, so just a couple more things that we have to do. We need to find the area of this triangle, okay? And finding the area of that triangle, I'll do it over here. Okay, we have everything labeled. The area of that triangle is 1/2 the base times the height. Ugh. Okay, the base we found was 11.76. The height was 8.09. Okay, we did our SOHCAHTOA to find both of those dimensions. So half of 11.76 times 8.09. I'm just going to do that in my calculator, except I'm going to put half as a decimal. I'm going to do 0.5 times 11.76 times 8.09. And that's going to give me 47.57. Okay. All right, we are so close to being done. This was the area of this triangle right here. Okay. I want 5 of them going all the way around the circle. So I'm going to take that number, 47.57, which is already in my calculator, and I'm just going to take that times 5, which is 237.8. 237.8. And that is in inches squared. Okay, so that one was a lot of work just because they didn't already give us the base and the apothem. They gave us that 10. Okay, so we had to use SOHCAHTOA to find those other two things. Now, one more thing I will add. How do we know that this is 36 degrees? They kind of gave that to us, but they didn't originally give that to us. How do I know that that's 36? Well, in that 5-sided figure, okay, if we take 360 and divide by 5, this whole length across here, that whole degrees, this is 72 right here, 72 degrees, but then half of 72 will give us just that little piece, which is 36. Okay, so that's kind of how they went through and figured out how many degrees that was, because they didn't originally give it to us. The only thing they gave us was 10. So it's kind of amazing that you can find out what the area of this guy is by just having one piece of information. That's all that we had to start with, and we found the entire area of it, okay, by kind of picking apart and finding things, okay. All right, last thing is composite figures. So composite figures are figures where a bunch of shapes are stuck together. So they have this guy right here, and they want us to find the area of, this is a putting green at a miniature golf course. Okay, so they must have like a sidewall here that's covered in this carpet stuff. This bottom is a trapezoid, and then that's a 2 across the top there. So what I do when I'm looking at composite figures is I figure out what shapes are involved. Okay, so in this case we have 3 shapes involved. 1, 2, 3. Okay. All right, so I'm going to find the area of each one of those shapes, and I'm going to add them together. So the first shape let's do is the semicircle. Okay, the second shape right here is a trapezoid, and it doesn't matter which one you put in which order, so I could have done the semicircle last. And then the last one is a triangle. Okay, so I'm going to find each one of those individually, which we know how to do. We have the formulas, and I'm going to add those all 3 together. So semicircle, to find the area of a circle, is pi radius squared. Okay, but since it's only half of a circle, I'm going to take that pi radius squared and I'm going to divide it by 2. Okay, so let's go ahead and do this semicircle. I have pi times the radius squared divided by 2. The radius, this whole length across here is 2. So the radius here is going to be just 1. Okay, so I have pi times 1 squared, and 1 squared is just 1. So really this is just pi divided by 2. So let's get a decimal here. Pi divided by 2 is 1.57. So the semicircle is 1.57 as an area, okay? The trapezoid, the formula for trapezoid is 1/2 the height times base 1 plus base 2, okay? So I'm just going to plot my numbers in there. 1/2 the height here, from here to here, that height is 7. They have it listed out over here. So the height is 7. Base 1, one of my bases is 2. The other base is 4 on the bottom here. Okay. All right, so I have half of 7 times 2 plus 4. 2 plus 4 is 6. Okay, I'm going to do this backwards. I'm going to do half of 6, which is 3, and then I'm going to take 3 times 7, because I can do that in my head. Okay, 3 times 7 is 21, so the area of the trapezoid is 21. Okay, last one, I have the triangle, and area of a triangle is 1/2 base times height. Okay, my base here is 3.25. And my height is going to be, let's see, 7.75? 7.75, there we go. Okay, all right, I'm going to do this one on my calculator because I can't do decimals very well in my head. But half I'm going to write as 0.5 times 3.25 times 7.75. That one, his area is 12.59. Okay, so composite figure, I have pieces, all 3 together. I'm going to add those all up. So 1.57 plus 21 plus 12.59. Let's see what we get. 1.57 plus 21 plus 12.59. And that composed area is 35.16 feet squared. Okay, so they will do this to you probably like on questions like on the ACT. Not really hard. You know how to find the area of a trapezoid. You know how to find the area of each one of those figures. Okay, just plop them in and then just add them all together. Okay, all right. Last one. I'm not going to go through this one, but I'm just going to kind of explain to you how this would work. This is finding the area by subtracting. So what I can see here is that if I would take this area, this is the area of a rectangle, it would be 5 times 6, okay? 5 times 6 is going to be 30, but that would be if I had the entire area filled in. I am missing this little triangular chunk, okay? So what I would do is I would need to find the area of that triangle. Triangle. and I would subtract that away from the 30 to get the area of this guy filled in, okay? Now, the problem with finding the area of that triangle, we would have to do some work, and that's why I'm gonna skip this so this video isn't terribly long. But to find the area of this triangle, this base here is 6. I would have to know base times height. Well, I don't know what the height here is, okay? So I'd have to use like the Pythagorean theorem with this triangle here probably. This guy's 3, that guy's 4, but this is not a 3, 4, 5, because 5 would have to be the hypotenuse. So I'd have to use the Pythagorean theorem to find that guy to figure out what his area is, okay? So I'm not going to quite do that, but I'm just showing you that this area can be found by subtracting rather than adding the figures together, okay? So when you have a chunk that's missing, sometimes it's easier to do it that way than to like separate this out into pieces. I don't know how you would even cut that. I don't know. Maybe make 3 triangles here, this guy, and this guy, and this guy. I don't know. That would be really hard. So finding the rectangle and then subtracting out the triangle is the best way to go for that. Okay?